Good morning, students. So last time we have started with the queuing system. So MM1 queuing system we are doing. So customers are coming in the system uh, according to the Poisson process. That means the inter-arrival times are exponential with the rate lambda. Service time distribution is exponential with the rate mu, and one server is there. Okay, so that we are parameters we have find it out. So let us continue that. So last time we have started with the MM1 queuing system. So now we have find out the parameters of the queuing system. Now we want to find out the CDFs of random variable Q, W, small w. Okay. So this is the CDFs we want to find out. So when n is equal to 0, that means no customer is there in the queuing system, then there is no queuing for service. Therefore, WQ0 is probability Q is equal to 0. That means in the queue there is no customer. This is probability that n is equal to 0, and we know that probability n is equal to n is rho raised to power n 1 minus rho. We have already defined it out for MM1 queuing system. So therefore this value is 1 minus rho. However, if a customer arrives when n customers are already in the system, then this arrival has to wait through n exponential service times. So if n customers are already there in system, so whenever a new arrival comes, so then all the customer has to go, then it will get the service. So therefore it has to wait n exponential service times. So given that, so given n is equal to n, Q is S1 plus S2 plus Sn, where Si's are IID exponential with parameter mu. So therefore Q given n is equal to n will follow gamma with parameter n comma mu. So therefore the PDF of Q given n is equal to n T is mu raised to power n gamma n e raised to power minus mu t raised to power n minus 1. This is the PDF of thus if for n greater than 0, probability Q is less than T given N is equal to N is nothing but 0 to T density x dx. So this is the value we have. Now probability Q is greater than 0 less than T is clearly, you know that this can be written as summation n is from 1 to infinity probability Q is less than T given n is equal to n, probability n is equal to n, because you know that this probability Q greater than 0 less than T is the expectation of probability Q greater than 0 less than T given n. Okay, so therefore this can be written in this fashion. This is summation probability Q is less than T given n is equal to n, probability n is equal to n. Okay, so this is nothing but summation n is from 1 to infinity integration 0 to T mu raised to power n, this value, x raised to power mu, okay, x raised to power, okay, so this is mu raised to power n, okay, x raised to power n minus 1, this value, e raised to power minus mu x upon n minus 1 factorial, because gamma n, that is n minus 1 factorial, if n is positive integer. Then into probability n is equal to n. So this is this is rho raised to power n 1 minus rho. That means 1 minus lambda by mu raised to power n dx. So this is the value we are getting. Now this is this can be written as 0 to T lambda e raised to power minus mu x, then 1 minus lambda by mu, and summation n is from 1 to infinity lambda x raised to power n minus 1 upon n minus 1 factorial dx. So we have adjusted all the terms here. Now this value, can you tell what is this value equal to? This summation is e raised to power lambda x. Okay, so therefore this is lambda by mu 0 to T mu minus lambda e raised to power minus x mu minus lambda dx. Taking this term together, we are getting this value. Now this is something integration lambda 1 e raised to power minus x lambda 1 x. So this you know that is CDF of the exponential distribution. So therefore this is lambda by mu is rho, and this value is 1 minus e raised to power minus mu minus lambda t, using the CDF of the exponential distribution. So therefore this can be written as mu 1 minus rho t because this is lambda minus mu. Lambda minus mu can be written as mu into 1 minus lambda by mu. Lambda by mu is rho. So therefore this value is rho 1 minus e raised to power minus. Now you know that W is L by lambda, which is rho upon lambda 1 minus rho. But rho is lambda by mu, so 1 by mu 1 minus rho. So therefore average time spent by the customer is 1 divided by mu upon 1 minus rho. So therefore this can be written as T by W. Okay, so now for T greater than 0, CDF is nothing but probability Q is equal to 0 plus probability Q is greater than 0 less than T. So therefore this is 1 minus rho, because already we have calculated probability Q is greater than equal to 0 is 1 minus rho, plus rho 1 minus e raised to power minus T by W. So therefore this is 1 minus rho e raised to power minus T upon W. So this is the CDF of random variable Q. Q is the time spent by the customer in queue, in the queuing system. So any question till now? Okay, am I audible?
Yes, sir.
Okay. So this is the basically CDF of Q. Now let us find out what is the CDF of small w. That means time spent by the customer in the queuing system. So if customer arrives when there are already n customer in the system, customer arrive when n customer already in the system. Then the total time spent by the customer in the system, because all these customers has to leave, then he has to basically get service, then he has to leave. So n plus 1, then the total time spent is sum of n plus 1. Okay, so that w, that means this value is basically nothing but this value n plus 1 exponential times mu. So therefore w given n is equal to n, will follow gamma with the parameter n plus 1 comma mu. So therefore the density of w given n is equal to n t is mu raised to power n plus 1 upon gamma n plus 1 e raised to power minus mu t raised to power n plus 1 minus 1. Okay, that means n t is greater than 0. Now what is wt? WT is the CDF of small w, probability W is less than equal to T. Now again using the same thing, expectation of probability W is less than T is expectation of probability W is less than T given N, that can be written as summation N is from 0 to infinity, probability W is less than T given N is equal to N into probability N is equal to N. Now this quantity can be written as summation N is from 0 to infinity, integration 0 to T mu raised to power n plus 1 x raised to power n e raised to power minus mu x, this quantity basically, upon n factorial, because n gamma n plus 1, because n is positive integer, therefore this is n factorial, and probability n is equal to n is 1 minus rho raised to power n dx. Rho is basically lambda by mu. So this is the value. Now this can be written as 0 to T mu e raised to power minus mu x 1 minus lambda by mu summation n is from 0 to infinity. Now because this mu is cancelling out, so we are left with lambda x raised to power n upon n factorial dx. Now this quantity is nothing but 1 plus lambda x plus lambda x squared divided by 2 factorial plus so on. So therefore this is the expansion of e raised to power lambda x. Now therefore this is 0 to T mu 1 minus, okay, 1 minus rho, because lambda by mu is rho. Now e raised to power this value minus mu and 1 minus lambda by mu rho x dx, because this is e raised to power minus mu, taking mu common, so we will get 1 minus lambda by mu. Lambda by mu is rho, so 1 minus rho x dx. Now this you know that is something 0 to T lambda star e raised to power minus lambda star x. So this is the integration of this is the CDF of exponential. So clearly this integration will be 1 minus e raised to power minus mu 1 minus rho T. But we know that from here mu upon 1 minus rho is 1 by W. So therefore this is 1 minus e raised to power minus T upon W. So therefore clearly this is also the CDF of the exponential distribution. So therefore small w, the time spent by the customer in the queuing system, follows exponential distribution with because parameter is 1 by W here. Cap W is the expected value of small w. Okay, because we know that expected value of small w is capital W. and 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 variance is W square. So this is the basically the answers for and also you know that the service time distribution is exponential with parameter mu. So whose CDF already we know is exponential for service time distribution. Now let us any question till now in the MM1 queuing system. Okay, now let us start with the MMC queuing system. So as the name suggests, the inter-arrival times are exponential. That means the arrival pattern is Poisson process with rate lambda. Service time distribution is exponential with parameter mu and C servers are there. Okay. So as already we know that first time denotes that the inter-arrival times random exponential inter-arrival times with rate lambda and the service time distribution is also exponential with rate mu, that means mean is 1 by mu, and C servers are there. C identical servers are there. So clearly we have the state transition diagram. So customer are coming with the rate lambda and the service is provided with rate mu, and when there is one customer, so you will get the service with rate mu. When there are two customers, because C servers are there, so 2 mu, and when there are C minus 1 customer, then rate will then corresponding death rate is C minus 1 mu. When there are C servers are there, so this is C mu, and also when C plus 1 are there, customers are there, then C are getting service because C servers are there. So therefore rate remains after that C mu. Okay, so this already, although we have discussed previously also when we are doing the birth and death process also. So is it clear to everyone that how we are getting these rates? Because C servers are there, so for when C to C minus 1 we are going C mu, when C plus 1 to C we are coming, then because C plus 1 C servers are busy and one is in line in queue basically. So whenever one of them will get service, then we will get from C plus 1 to C, that means that is C mu. So lambda n is lambda n is 0, 1, 2 and so on, and mu n is n mu when n is 1, 2 up to C, and this is C mu when n is C plus 1, C plus 2 and so on. Now we want to solve. So can anyone tell this is a birth and death process? So how to find out value of Pn, probability that n is equal to n, as capital N is equal to small n? How we find out in birth and death process? So in birth and death process, we know that we will find out S, which is 1 plus C1 plus C2 plus Cn and so on. So then P naught is 1 by S and Pn is Cn P naught. So first of all, let us determine what is Cn. This is lambda naught, lambda 1, lambda n minus 1 upon mu 1, mu 2, mu n. Okay, so therefore let us denote by A as lambda by mu and rho as A by C, and already we know that when we have done the birth and death process, then we know there we have calculated that when rho is less than 1, then steady state solution exists. Or limiting probability exists. So now this value, this is when n is 1 2 up to C, then this will be lambda 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 upon mu 2 mu so on to n mu. Okay, this will be lambda n upon mu 2 mu so on to n mu, and when n is C plus 1, C plus 2 and so on, then that will be lambda C, lambda raised to power n minus C upon mu 2 mu C mu, then C mu raised to power n minus C. So this is the value, because this is the values we are plugging in basically of mu 1, mu 2, mu n. Now this value is, because we have taken A as lambda by mu, so A raised to power n upon n factorial, n is 1 to C, and we have this value can be written as A, because lambda by mu, AC upon C factorial, and this quantity is remaining. This is lambda upon C mu raised to power n minus C. So therefore rho raised to power n minus C. So n is C plus 1, C plus 2 and so on. So this is the value we are getting. Now we know that S, which is 1 divided by P naught, is 1 plus C1 plus C2 plus so on. So therefore, this will be summation n is from 0 to c minus 1 an upon n factorial. From here you can see, because this is cn value, and plus cn will be uh, so you can just write down. First of all, let me say that first you write down, then you just this will be 1 plus a square divided by 2 factorial from here, plus a c minus 1 upon c minus 1 factorial, plus ac term ac upon c factorial, then 1 plus from here c plus 1 term is ac upon c factorial into rho plus rho square plus so on. So this is the value you are getting. Now this can be written as summation n is from 0 to c minus 1 an upon n factorial plus ac upon c factorial into this summation is 1 minus rho. So therefore this is the value. So therefore from there we can find out the p naught value. P naught is nothing but S inverse. S is this value. So Pn is, yes, so what is the value of Pn in terms of C1, C2?
Cn P naught.
Yeah, Cn P naught. So Cn P naught. So now this is clearly this value an upon n factorial P naught, when n is basically your 1, 2, 3 and so on. And this is an upon c factorial rho raised to power n minus c p naught when n is greater than equal to c. So this is c and p naught value. Now okay, so this can be written as okay. Now let us determine what is the value of what is the probability that an arriving customer must queue for service. Okay, probability that an arriving customer must queue for service if and only if there are C customer or more than C customers are there, because number of servers are C. Okay, so n should be greater than C. So this is basically denoted by C comma A. This is known as the Erlang C formula. So therefore, or Erlang delay formula. So therefore, probability that arriving customer must queue for service when there are either C customer or C plus 1 customer or C plus 2 customer and so on. So therefore this is summation n is from C to infinity Pn. So therefore this can be written as 1 minus summation n is from 0 to C minus 1 Pn. So therefore this is 1 minus now Pn is Cn P naught, but this is An upon n factorial into P naught. So therefore 1 minus P naught summation n is from 0 to C minus 1 An upon n factorial. So therefore this is 1 minus summation n is from 0 to C minus 1 An upon n factorial upon P naught is 1 divided by this 1 by S inverse. So therefore this is summation n is from 0 to C minus 1 An upon n factorial plus AC upon C factorial 1 minus rho. So we are left with AC upon C factorial divided by 1 minus rho we are dividing. So this is 1 minus rho summation n is from 0 to C minus 1 An upon n factorial, just taking this to other side, plus AC divided by C factorial. Now, okay, so no, let me write down in this fashion. This is upon 1 minus rho, 1 minus rho. Okay, so this is nothing but AC upon C factorial 1 minus rho P naught, because P naught is this value 1 divided by summation n is from 0 to C minus 1 An upon n factorial plus AC divided by C factorial 1 minus rho. So therefore this is the probability that an arriving customer must queue for service. So from here also we can determine P naught is C factorial 1 minus rho C comma A underlying C formula A raised to power C. So this is the value for P naught, and let us determine what is the okay arrival rate, average arrival rate. This is the rate in which customers are rate with which customers are coming into the probability with which they are allowed in the system. So all the customers are allowed in the system. So therefore lambda is equal to lambda. Also, what is LQ? That means average number of customers in queue. So because when there are C customer, summation n is equal to C to infinity n minus C into Pn. That means when there are C plus 1 customer, then 1 into, because 1 customer in queue, 1 into P C plus 1 and 2 into PC plus 2 plus 3 into PC plus 3. So that is the LQ basically. So therefore this is summation n is from c to infinity n minus c, and when n is greater than equal to c, then Pn is Cn P naught. So this will be Cn P naught. So this can be written as because rho is also A upon C. Rho is also A upon C. So therefore this can be written as AC. A n minus c upon c raised to power n minus c. That can be written in that fashion also, c factorial. Because this can be written as AC a raised to power n minus c upon c factorial and c raised to power n minus c. Okay, this can be written in this fashion also. So therefore, using that, we can write down. So this is AC a n minus c upon c factorial c raised to power n minus c p naught. So therefore this will be p naught AC upon c factorial summation n is from c to infinity n minus c AC a n minus c upon c raised to power n minus c. Now, okay, no need to write that thing also. Yeah. Okay, so this is also sufficient. Rho raised to power n minus c. Why to complicate? Yeah, so this can be written as rho raised to power n minus c. Now this quantity is summation. Take n minus c as some k. So k from 0 to infinity, k rho raised to power k. Now this can be written as p naught AC upon c factorial. Take one row common and we will get summation. K is from 0 to infinity, k rho raised to power k minus 1. So this quantity can be written as summation k is from 0 to infinity and derivative of rho raised to power k, because that will be k rho raised to power n minus 1. Then we take derivative outside and summation inside. Summation rho raised to power k. Now this quantity is nothing but derivative of 1 plus rho square plus so on. So that is 1 minus rho, and derivative of this will be taking the derivative. So this will be 1 divided by 1 minus rho square. Okay, so therefore this quantity becomes P naught AC rho upon C factorial 1 minus rho square. So this is the answer we are getting here. So whether in terms of C, because P naught value we can plug in, so then we will get answer as you can just check rho C comma A, underlying C formula 1 minus rho. Now this is LQ. What will be WQ? Average time spent by the customer in Q. So can anyone tell the relationship between LQ and WQ? LQ is the average number of customer in Q in the queuing system. WQ is the average time spent by the customer in Q. So using the Little's law, this is the LQ upon lambda A. Lambda is lambda. So therefore this is rho C comma A upon lambda 1 minus rho. Or whatever, you can plug in this value also. Okay, so this is the value for WQ. Now, what is the value of WS? Because service time distribution is exponential with parameter mu, so capital WS will be 1 by mu. Then what is W? Average time spent by the customer in getting service. That is WQ plus WS. Both the things we know. And what is L? L is lambda times W. Lambda A times W, Little's law. So these are the values which we are getting here in the MMC queuing system. So any question till now? Okay, so let us stop here. So next time we will try to find out the corresponding CDF, and then we will do MM1K and MMCC and MM infinity queuing system. Any question?